Hello again. We are continuing our discussion on linear equations by talking about literal equations and dimensional analysis. All right, so let's define some things. A literal equation is a formula that has several variables in it. So you would never actually use it to figure out the value of any one of those variables. You're just kind of rearranging it. And dimensional analysis is carrying units throughout a computation. So we're going to talk about examples of both of those. So let's say we have an equation and we want to solve for a specific variable. Let's say we have 3x plus 4y equals 18, and I want to solve that for y. What that means is I want to rearrange things so that y is by itself on one side of the equation and everything else is on the other side. So since 4y is on the same side as 3x, that means I need to subtract 3x from both sides. And what that gives me is 4y equals 18 minus 3x. I've still got a 4 on the same side as the y, so I need to divide that out because it's being multiplied by the y. So that means I have 4y divided by 4 equals 18 minus 3x, all divided by 4. The 4's will cancel, and I have y equals 18 over 4 minus 3 over 4x, okay, which I could simplify to y equals 9 halves minus 3/4 x. Okay, it doesn't look nice, it's just a rearrangement of that same equation though. All right, solving for a specific variable. Here's another example. If I have 4m minus 5n equals mp plus 8, and I want to solve that for m, that means I need to get m by itself on one side of the equation and everything else on the right-hand side. But notice how the letter m shows up in two places. It shows up in the 4m and it shows up in the mp. So here's what I need to do. Any term that has an m in it, I need to get it on one side, and any term that doesn't have m in it at all, that's going to go on the other side. So I've decided to collect my terms that have m in them. I've decided to put those on the left. So to do that, I need to get rid of the mp that is on the right, and that means I will add negative mp to both sides. Okay, so the left-hand side is 4m minus 5n minus mp, and the right side I had mp plus 8, and now I'm subtracting mp, so the mp and the negative mp go away. I have 4m minus 5n minus mp equals 8. But there's still a problem because of that minus 5n that is on the left. I wanted to collect my m terms on the left. 5n is not one that I want over there. So since it's a negative 5m, I'm going to add 5n to both sides. And when I do that, it goes away from the left-hand side, but it shows up on the right-hand side. I have 4m minus mp equals 8 plus 5n. Now every term that has m in it is on the left, every term that doesn't is on the right. So I'm going to use reverse distributive property to factor m on the left. Every term on the left has an m in it, so I can factor that out and write the leftovers in parentheses, kind of like the question of distributive property would look like. So you're kind of working backwards. So if I take m out of 4m, I'm left with 4, and if I take m out of negative mp, I'm just left with the negative p. So that's what it looks like if I were to do distributive property backwards. So m times 4 minus p equals 8 plus 5n. Now m is being multiplied by everything in those parentheses. So I can divide both sides by the 4 minus p. And that's what it looks like. All right? So those will cancel out, and I will be left with m equaling 8 plus 5n over 4 minus p. Okay? So now let's look at some literal equations and using them. The volume of a square pyramid is given by that formula there, where v is the volume, s is the side length of the square, and h is the vertical height. So if I wanted to solve this for height, that means I need h by itself on one side of the equation and everything else on the other. So if I multiply both sides by 3, then I get 3v equals s squared times h. And if I divide both sides by s squared, that means that the s squareds will cancel on the right, and I will have h equaling 3v over s squared. Okay? So if I wanted to now use this equation to find the height of a pyramid where the volume was 12 and the side length was 2, I have v, I have s, and I just plug those in. v becomes 12, s becomes 2, and now the left-hand side is all numbers. And all of that is worth 9, so that means that the height of that pyramid would be 9. All right, so here's some dimensional analysis. Let's say I have a car that is traveling 35 miles per hour, and I want to know how fast it's traveling in feet per second. So I know that a mile, which is what I was given, is 5280 feet. That's the unit I want to convert to. And I know that an hour, which is what I was given, is 3,600 seconds, which is the unit that I'm trying to convert to. So I start off with 35 miles per hour. That's 35 miles in 1 hour. And the key here is to multiply by fractions where the top and the bottom are worth the same, even though they're represented by different numbers. And while I'm doing that, I also need to cancel out the old units and use the new units. So the first thing I'm going to do is I'm going to multiply by 1 hour over 3,600 seconds. Both of those are worth the same amount of time, even though they're different numbers. And notice how the hours that were on the bottom will cancel with the hours that I've written on top. So now I've got something in miles per second. So I'm close, I just need to convert it to feet per second. I also know that 1 mile is 5,280 feet, so 5,280 feet over 1, those are worth the same, so it's like multiplying by 1, but the units are different. So notice how the miles on top of what I was given will cancel with the miles on the bottom of what I created. So now the only units that I'm left with are feet and seconds. Okay, so looking at the numbers that are on top, I've got a 35 and a 5,280 on top, and I've got 3,600 on the bottom. So if I figure out just the number part, that is 51.33, and my units end up being feet per second. So going 35 miles per hour is the same thing as going 51.33 feet per second. That is it for those two topics. If you have any questions, please let me know, and I will see you tomorrow.